Do you know how we get the information of whole world by watching television in the house? When we go on a journey and forget the route to the destination, then how the internet helps us to get on the destination. The prediction of weather we get from news. Do you know how we get this information? The answer of all the questions lie in the artificial satellite which helps us. So, is the artificial satellite much more important and how it looks like? Is the Earth where we live is also a satellite or not? We find the answer of this question in this video. A satellite system is a set of gravitationally bound objects in orbit around a planetary mass object or minor planet. So our Earth is also a satellite which revolves around the Sun, and the other planets also revolve around the Sun. Satellites are of two types: natural satellite and artificial satellite.
Artificial satellites. Artificial satellites are human built objects orbiting the Earth and other planets in the solar system. Artificial satellites are used to study the Earth, other planets, to help us communicate, and even to observe the distant universe. Satellites can even have people in them, like International Space Station and the Space Shuttle. The first artificial satellite was the Soviet Sputnik 1 launched in 1957. Following are the different types of artificial satellites. Communication satellites. Communication satellites are satellites stationed in space for the purpose of telecommunication. Modern communication satellites typically use geosynchronous orbits, Molniya orbits, or low Earth orbits. Geosynchronous orbits, in which a satellite takes 24 hours to orbit the Earth, allowing for communication and television broadcasts. Astronomical satellites. Astronomical satellites are satellites used for observation of planets, galaxies, and other outer space objects. Biosatellites. Biosatellites are satellites designed to carry living organisms, generally for scientific experimentation. Earth observation satellites. Earth observation satellites are satellites intended for non-military uses such as environmental monitoring, map mapping, etc. Navigational satellites. Navigational satellites are satellites which allows navigation system to measure location to accuracies on the order of few meter in real time. Weather satellites. Weather satellites are primarily used to monitor Earth's weather and climate.
We are going to cover spacecraft subsystems. The spacecraft can be divided into two major parts, the payload and the bus. The payload represents what the mission does and why we are going into space. The bus consists of all the parts that support the mission. Generally, the payload takes up approximately 30% of total spacecraft mass, and the rest of the subsystems or the bus is the remaining 70% when designing spacecraft. We start with payload sizing. We determine the size, weight, and power requirements called SWAP for the payload. Then we can estimate the SWAP for the spacecraft as a whole. This process is very iterative, starting with the payload. In the mission, we first answer the question how much we take the payload. Once the payload is determined, we can move to all the supporting subsystems. The first subsystem we are going to look at is Attitude Determination and Control Subsystems, are known as ADEX. The purpose of this subsystem is to control and monitor the rotation of the spacecraft. This subsystem answers the questions: where am I pointing? Where do I want to point? And how do I maneuver the spacecraft to that point? Next major components are the instruments that aid the spacecraft to move or rotate so it can point in the desired direction. Such instruments are reaction wheels, thruster, and magnetic torques. The last major component of this subsystem are the sensors that allow the satellite orientation to be made. These sensors enable the satellite operator to determine the orientation of the satellite, answering the question of where it is pointing. Examples of such sensors are Earth, Sun, and star sensors, gyroscopes and accelerometers, and position, navigation, and timing are known as PNT sensors. After that, we move to the Guidance, Navigation and Control Subsystem, or simply the GNC. The purpose of the GNC is to control or maintain the orbit of the spacecraft and to move into a desired orbit. Propulsion subsystem is the primary actuator for the guidance, navigation, and control subsystem. The propulsion subsystem is to move the spacecraft into a desired orbit or maintain the satellite in its current orbit and perform station keeping operations such as firing a thruster to help maintain orbital altitude to overcome the atmospheric drag. However, the propulsion subsystems are made up by thrusters, propellant tanks, and the plumbing which connects the tanks to the thrusters. After the propulsion system, we move to the electrical power subsystem or EPS. The electrical power subsystem is responsible for the generation, storage, and the providing electrical power for the entire spacecraft. Most satellites use solar arrays to generate and provide electrical power to the spacecraft. Solar arrays are also providing power to the batteries for the storage. So, when the satellite is not in the view of the sun, batteries are used to provide spacecraft power and a power management and distribute it. It is responsible for allocating the power in the correct voltages and current to the rest of the satellite. Now we talk about thermal control subsystem. The thermal control subsystem helps protect electronic equipment from extreme temperatures due to intense sunlight or the lack of sun exposure on different sides of the satellite body. Now we talk about the structure subsystem. The functions of the structure subsystems are to enclose, protect, and support the other spacecraft subsystems, and to provide the mechanical interface with the launch vehicle. The structure must also sustain the stresses and loads experienced during environmental testing, launch, perigee, and apogee firings, and deployment of booms, solar arrays, and antennas. The next subsystem is the communication subsystem. This subsystem allows the ground to send commands to the satellite and disseminate information such as satellite positions and payload guided to the ground. This subsystem is proudly made up of transmitters, receivers, and antennas. It is important to note that the communications can be the missions of the spacecraft, but most spacecraft need to receive commands. The last subsystem we will cover is the commanding and data handling subsystem. This subsystem is the brains at the spacecraft. It manages, stores, and controls all ground commands, payload data, and telemetry turn all phases of the spacecraft mission. To do all this commanding and data handling, first element in this subsystem is the CPU. It works like a typical computer. The next element is the memory. The memory stores the operating system program applications, status of payload data, and the memory element are the links that connect our interface with the sensors. Now we will end the video. Hope this was informative to you. The future belongs to the curious, the one who are not afraid to try it, explore it, question it, and turn it inside out. So stay curious and keep exploring. Thank you for your time.